Hello, my name is Jason Chanko, and I'm the Applications Marketing Manager for Siglent America. Today we're going to take a closer look at the Siglent SSA3000X series of spectrum analyzers. These analyzers were released in early part of 2016, and since then many RF electrical and radio or broadcast engineers, as well as hams, have been using these instruments to help them troubleshoot their RF issues. In this video, we're going to highlight some of the reasons why the SSA3000X has become so popular. There are currently two models available. The SSA3021X operates from 9 kHz to 2.1 GHz, and the SSA3032X operates from 9 kHz to 3.2 GHz. Both are based on a swept superheterodyne design that has historically provided great performance without a high price tag. Let's pull up the datasheet for the SSA3000X and take a closer look at some of the features and benefits. DANL stands for Displayed Average Noise Level, and it indicates the noise floor of the instrument. Lower noise floor values enable you to observe lower power signals. This is especially important when you are hunting for harmonics of a signal or potential interference sources. The SSA3000X has a DANL of -161 dBm per Hertz typical. The written spec is commonly normalized to 1 Hz, so the displayed noise floor of the instrument is typically near -151 dBm in actual use, as we see here. The SSA3000X also features a 10 Hz minimum resolution bandwidth setting. This provides a lower noise floor and also provides a better frequency resolution when you're comparing it to the minimum resolution bandwidth of 100 Hz found on similar analyzers. Basically, the lower the resolution bandwidth, the closer you can discern between two signals that are close together, and also it has the added effect of lowering that band or lowering the DANL or noise floor. Now let's take a look at phase noise. This is a result of small thermal fluctuations in the circuit elements of your RF source you are testing, as well as the spectrum analyzer input circuit. It's similar to jitter with an oscilloscope or function generator. To accurately evaluate the performance of an RF source, such as an AM transmitter, local oscillator, or clock circuit, the phase noise of your measurement system needs to be lower than the phase noise of the transmitter. The SSA3000X delivers with respectable phase noise of -98 dBc per Hertz at a 10 kHz offset. The SSA3000X also features a 10-inch WVGA display, and it does measure a full 10 inches, there 10.1, and we've got about 7 inches of actual trace area. And also, when you slow down the resolution bandwidths and the sweep, you'll see that there's a progress bar that helps indicate exactly where you are located in the frequency space, which is nice. The instrument also features the ability to show up to 4 traces simultaneously. This is 4 versus the 3 that is available in many other spectrum analyzers. Having the ability to view 4 traces simultaneously and being able to configure them each separately allows you to compare more of the traces that you've collected using different setups for the instrumentation or any particular parameters that you may have adjusted while you were performing the data collection. So you can almost use it as a reference hold, similar to an oscilloscope reference hold. It can be helpful when you're troubleshooting multiple scenarios or different measurement environments. And now we're going to take a look at the save feature. We're going to insert a USB stick and we're going to press File, and now you'll see that the save type, we have a number of formats. We can also have JPEG and bitmap, and those are going to be mapped directly to the save key. Every time we press the save key, it's going to open up a file dialog, save as JPEG, and now we press enter to save to the USB stick, which is indicated here. But we can also go back and to display, and we can change that to an inverted image. That's going to save you on ink when you go to print. The next option that I'd like to introduce is the EMI Tool Kit for the SSA3000X. The EMI Tool Kit is going to be helpful if you're going to be performing any troubleshooting or pre-compliance measurements on your product prior to taking it in for full compliance testing. So the main idea here is that you're going to get data that is going to allow you to understand whether you're going to pass compliance testing on the first pass, or if you maybe need to go back and perform a little bit of tweaking to your design in order to make sure that it's going to pass the first time through your compliance test lab. Some of the things that come with this particular feature are going to be the EMI filter. We can enable that by pressing the bandwidth key and then enabling EMI. And once you've enabled the EMI filter, again that's a 6 dB filter as compared to the normal 3 dB Gaussian filter, that 6 dB EMI filter is then going to enable you to select resolution bandwidths of 200 Hz, 9 kilohertz and 120 kilohertz. Those are defined bandwidths for the FCC as well as CISPR measurement standards for compliance. And then we're also going to be able to activate the quasi-peak detector, so we can press detect, and now you'll see that the quasi-peak detector is available and we can select that. Some other helpful features here with the SSA when it comes to performing pre-compliance measurements, we can normally we have log amplitude and linear frequency, but in pre-compliance applications or compliance applications, we typically see log. If we press the span key, we'll see that the X scale can be changed to log. So now we've got log amplitude as well as log frequency. And now we can enable limits. Pressing the limit key, we've got 2 limit lines. Many spectrum analyzers will not have 2 full limit lines. They'll have an upper and a lower. In this case, we've got 2 limit lines that we can select to be upper or lower. In this case, we're just going to turn on limit line 1 and turn on limit line 2. Now we can visualize the 2 limit lines that we need to meet, or we may need to meet for this particular application, and then our electromagnetic performance of our device under test shown under the yellow trace here. Both of the limits can also be edited. They've got a line mode as well as a point mode, and in the point mode you can see that we've got the x-axis as well as the amplitude values for each of the points in that particular test. All of these features are very helpful when you're performing pre-compliance, and there's also a software application that can help to sequence a lot of the data collection. The SSA3000s are also available with the Advanced Measurement Kit, or AMK option. The AMK option includes a number of standard measurements used in broadcasting. If we press the measure key, we'll see channel power, adjacent channel power, occupied bandwidth, total power, third order intercept, and spectrometer. I'd like to show the spectrometer because this is also a feature that isn't available on many other spectrum analyzers. By pressing the spectrometer, we'll see now we have a sweeping waveform going, or a sweeping trace. The frequency is sweeping from a start frequency to a stop frequency, and then over time with each successive pass, we're actually seeing the waterfall chart located here on the bottom from minus 10 dBm in red to minus 110 dBm in blue, and then it's tracing each successive trace as being stacked on top of one another, so that over time we're starting to see the actual trending. If we had frequency hopping or we were bouncing between different zones or different frequency values, we'd be able to then very clearly indicate that using that waterfall charting feature. Very helpful. And the final option that I'd like to cover today is a tracking generator. A tracking generator is a swept RF source that follows the analyzer frequency steps. It's typically used to test filters, amplifiers, and cables. The tracking generator hardware from Siglent is included with all versions of the SSA3000X family. With some competitive analyzers, you have to order the hardware when you buy the analyzer. There isn't an upgrade later on. You'd have to trade in your system that does not have the tracking generator option and purchase a unit that has that hardware. With Siglent, you purchase the hardware. It's included. If you don't want the feature, you don't have to buy the license and you don't have to activate it. If you do purchase a unit without the TG option enabled, your upgrade is available at any time. You just, to activate the TG option on the Siglent SSA3000X, all you have to do is call your nearest Siglent office or distributor, purchase the option, and enter the license key. Unlike many analyzers, the TG also operates to the maximum frequency of the instrument, not just to 1 gigahertz. So if you have a 2.1 gigahertz unit, the tracking generator operates up to 2.1 gigahertz. That makes the TG option even more powerful, giving you a full bandwidth capability or full frequency span capability to test your passive and active devices. I hope that this little walk around for the SSA3000X has been helpful. If you have any questions, please contact your nearest Siglent dealer. Thank you, and have a great day.